Today we are going to be deriving the sine and cosine addition formulas. So sine of a plus b and cosine of a plus b, where a and b are real numbers. I'm not sure, they could probably be complex numbers, I'm not 100% sure about that, so let's just focus on real numbers, though it really won't make a difference in the proof. So I actually don't remember what they are, but as long as you do the steps correctly, you can pretty easily get them, as long as you know one particular formula, and that is Euler's formula. So I'll just put like a little no that e to the I theta is equal to cosine of theta plus I times sine of theta. Okay, this is really important, okay? So this is a way to convert exponentials to trigonometry, and it's a very useful connection between complex numbers, exponentials, and trigonometry. This is derived, I think there are a few ways to do it, but I think the most popular way is through Taylor series expansion, so that's like calculus 2 stuff, but that's not necessary, you don't need to know how to derive it, you just need to know it for this one, okay? So let's start. We're actually going to derive both of them at the same time, so let's just begin. So the first thing I want to do is I want to take cosine of a plus b plus I times sine of a plus b. And the reason why I'm doing this is because we can use this, kind of go backwards, and say that this is e to the I times a plus b, because a plus b is kind of our theta in this case. So this is going to be equal to, I'll just write it this way, this is e to the I times a plus b. Okay? And then it's very easy, we can go from there, we can say that this is e to the IA plus IB just by distributing. And then we can say, we can use the multiplicative thing about exponentials, that little property, useful little property. We can say this is e to the IA multiplied by e to the IB. Okay? And so then from here, what we can say is we can actually use this again and convert this from an exponential back to a trigonometric form. Okay? So from here we can say that this is I'm going to say it like this. So we have cosine of A plus I times sine of A, and that multiplied by cosine of B plus I times sine of B. Okay, and this comes from this first one, and then this comes from the second one. Let me make that parentheses better. Okay, so then from here, we can just multiply out. So let's just make sure we do this properly. So we get cosine of A times cosine of B. So I'm just going to do cosine of A times cosine of B plus cosine of A times I sine of B. So plus cosine of A times I sine of B. And then we have I sine of A times cosine of B. So plus I sine of A times cosine of B. And then last but not least, I sine of A times I sine of B. This I times I is -1, so we're going to change this to a minus sine of A times sine of B. Okay, sorry if, yeah, it's a little slanted, but oh well. Okay, so now what I want to do is I want to group the real portions and then group the imaginary portions, which are these two, and then I'm going to factor out the I from the imaginary portion, and then we'll see what we get. Okay, so I just cleaned it up a little, made it look a little nicer, and I wrote down this portion. Basically, I just kind of grouped everything together. So I grouped the real part, so that's this and this. I put it in this set of parentheses, and then I put this and this together. Wait, yeah, this term and this term, I put these together and factor out the I, and that's all I did. So now we can compare that this is the same as this, which means that the real part of this is going to be the same as the real part of this, which means that cosine of A plus B is exactly equal to this, and then the imaginary parts are also going to match. So we have sine of A plus B equal to that. So I can highlight this, so we get cosine of A plus B is equal to this, and then we have sine of A plus B So I'm excluding the I because the I is the same on both sides, but all we want is sine of A plus B. That's equal to that. So let me just explicitly write those out, and then I'll come back. Okay, so yeah, I just wrote it down there just so you can see clearly the formulas for sine of A plus B and cosine of A plus B. And I think this is super elegant to prove it just by knowing this one formula, and you can very easily show this. And I love trig proofs like this. I might do a couple others that come from like doing stuff like that with complex numbers. Some of the other trig proofs are kind of annoying, but yeah, I might do some more of this kind of stuff if you guys enjoy. So thank you so much for watching, and I'll see you in the next video. Bye guys!